Okay, so for section 2, what I did is I separate the lecture into two. One on Tuesday and one on Wednesday. So maybe for you guys, I will cover the whole lecture for today, and maybe tomorrow we will have no class. Okay. Is that okay for you guys? So if okay,
Okay, sir. Okay, sir.
so okay, kita boleh rehat esok. Okay, so we move on into new chapter today. So in chapter 4, you have learned about root locus. So root locus basically plots the poles of a transfer function as the gain changes. So you will get a type of graph, and you can determine the stability from the graph. And in this lecture, chapter 5, we are going to learn um, new types of plot. So we call this frequency response techniques. There are two types of plot. First is Bode plot, and the second one is Nyquist. Okay, so this plot basically describe plot the transfer function also, but it plots the transfer function uh, by varying the frequency of the system. So instead of varying the gain, these two plots vary the frequency. Okay, so students will be able to recognize gain margin and phase margin frequency using Bode plot. So there are two parameters that you will need to calculate in Bode plot, known as gain margin and phase margin. And these two parameters will be used to determine the stability from Bode plot. And same thing for Nyquist. You can also determine gain margin and gain margin frequency, and using this to determine the stability. Okay, so we look at Bode plot first and then Nyquist. Okay, so Bode plot basically is a graph that use logarithmic axis. So your usual or your normal graph basically has the same distance between the lines. But for Bode plot or logarithmic graph, your x-axis is in terms of log, okay, log 10. So if you still remember form 4, you have log 10, okay. So basically Bode plot use log 10 or logarithma. And why use log 10? Because in transfer function, in your transfer function later, you want to plot the magnitude or the angle for a large range of frequency. So you can have frequency from 0 until maybe up to 10,000, for example. So you can use log plot so that you don't need to have a very large graph. So instead of using large graph, you use log plot so that you can reduce the x-axis, okay? Reduce the size of the x-axis. And in Bode plot, there are two types. First is Bode magnitude plot, which usually expressed in decibel. And the second one is Bode phase plot, or usually expressed in degree, known as phase shift, okay? So as I said just now, Bode plot are widely used as a mean to display or communicating frequency response. So why use Bode plot? Because you can plot your transfer function for a wide range of frequency. So frequency is very long range, so you can squeeze them in one single plot. Okay. And in Bode plot, you have gain and phase. And the unique about Bode plot is that you display gain and phase in two separate plots. And both of the plots are in logarithmic, okay? So the horizontal axis or the x-axis will be a log scale of the frequency, log of the frequency. And the vertical axis can be either gain which is expressed in decibel, or the phase. Okay, later we will see an example. Okay, so this is an example of the Bode plot. So the top one is magnitude Bode plot. So if you look here, 20 log m here is decibel in terms of decibel. So if you want to convert magnitude, let's say magnitude m into decibel, so you use 20 log, okay, 20 log 10 m. So you get in decibel. And if you look at this graph, you can see that the x-axis is the distance of the x-axis varies, okay, from very large becoming very, very small. So this is log plot, okay. So you can plot from 0.1, and then the next one is 10 times, okay, 10 times 1, 10 times 0.1, so you get 1, and then 10 times 1, you get 10, and so on, okay. And the bottom plot is the phase or the angle, the phase angle of the transfer function. So the same x-axis, but the y-axis is in terms of angle. Okay, so one parameter, one of the parameters that you need to know in Bode plot is gain margin frequency. So gain margin frequency is the frequency at negative 180 degree phase. Okay, so when you look at a graph, let's say this graph, so when you have negative 180, then the frequency of this graph intersect negative 180 is the gain margin frequency. And then gain margin is defined as the gain required to raise the magnitude of the curve to 0 decibel from gain margin frequency. Okay, so later we will see how to use these two parameters and how to determine these two parameters from Bode plot. Okay, so gain margin frequency is the frequency at negative 180 degree. So here, 180 degree, you need to look at the intersection of the graph and then find the frequency at this intersection. So this is gain margin frequency, and gain margin is the difference of the gain at gain margin frequency with 0 decibel. Okay, so first you need to determine gain margin frequency, and then at gain margin frequency, determine the difference between 0 decibel and the gain from magnitude plot. Okay, so this one is gain margin frequency, and this is gain margin, and this is gain margin frequency. Okay, we have two more parameters. So the next parameters are phase margin frequency. Okay, so just now it's gain margin frequency, and now it's phase margin frequency. So it's the frequency at magnitude 0 decibel. And then we also have phase margin. So phase margin is defined as the difference between the phase at phase margin frequency and 180 degree. Okay, so let's look at how to determine this from Bode plot. So first you need to determine phase margin frequency. So phase margin frequency is the frequency at 0 decibel. So you need to look at intersection at 0 decibel and then determine the frequency. And then phase margin is the difference of the phase at phase margin frequency with 180 degree. So first determine phase margin frequency and then determine the phase at that frequency and then find the difference of that angle or the phase with 180 degree. Okay, so you have 4 things to remember for Bode plot. Okay, so here is another example of determining gain margin and phase margin. So first, let's look at gain margin. So first, we need to determine gain margin frequency. So gain margin frequency is the frequency at negative 180 degree. Okay, so when the graph intersect negative 180 degree, that's the frequency, gain margin frequency. Then to determine gain margin, basically you look at the gain plot or the magnitude plot and find the gain at gain margin frequency. Then the difference of the gain with 0 decibel is known as the gain margin. Okay, next is the phase margin frequency. So phase margin frequency is the frequency at 0 decibel. So when the magnitude plot intersect 0 decibel, then the frequency is the phase margin frequency. And then to determine phase margin, basically you look at the phase graph and then determine the phase at phase margin frequency. Then determine the difference of the phase with negative 180 degree. So you get phase margin. Okay, so let's look at how to determine stability using phase margin and gain margin. Okay, so this is frequency at 0 decibel. So frequency at 0 decibel is phase margin frequency. Okay, so this is phase margin frequency. And frequency at negative 180 degree is the gain margin frequency. So this is gain margin frequency. So whenever you have phase margin frequency less than gain margin frequency, then the system is stable. Okay, that's the only rules for Bode plot stability. Okay, stability using Bode plot. When phase margin frequency less than gain margin frequency, then the system is stable. So if you have phase margin frequency bigger than gain margin frequency, then the system is unstable. Okay. All right. So this is an example how to draw Bode plot. Okay. So let's say you are given a unity feedback system. So GS equals 10,000 divided by S plus 5, S plus 20 times S plus 50. Okay, so question asks you to draw the Bode plot, magnitude and phase plot, and then evaluate gain margin, phase margin, 0 decibel frequency and 180 degree frequency from your Bode plot and determine the stability of the system. Okay, so if you look at your quiz question, so I already list down the steps in plotting Bode plot. So the first step you need to do is to convert all S in the trans function equals J omega. Okay, so here you need to convert all of the S with J omega. Okay, so from this trans function, you need to convert S equals J omega. So this becomes okay. So first step, convert all S equals J omega. And then the next step is you determine the magnitude and angle at different omega value for each of the pole and zero. Okay. So the first pole is JW plus 5. Second one is JW plus 20. Third one is JW plus 50. And the last one is 10,000. So you need to, let's say the first omega is 0. So substitute 0 in all omega or W. So you get magnitude 5 and the angle is 0. So basically you need to substitute omega 1 by 1 and then determine the magnitude and angle. So what happens is that if magnitude is 0, if omega is 0, so you get this one equals 5. So if you plot in S-plane or imaginary axis, 5 is here. Okay, 5 is here. So magnitude is 5 and the angle is measured from real x-axis and it's 0, okay? No angle, so angle is 0. And then you repeat the process for each of the poles and 0. And then after that, you determine the overall transfer function. So overall transfer function for magnitude, basically magnitude is so magnitude will be equals to the product of magnitude of 0 divided by the product of magnitude of poles. Okay, so that's the formula for magnitude. So what this answer calculates basically 10,000 divided by 50 times 20 times 5. So you get 2, okay? And then for angle, basically angle is theta equals sum of angle of 0 minus sum of angle of poles. Okay, so this one I think you can refer back to notes of root locus, I think 4a. Okay, notes 4a. So to find angle, basically you sum 0 minus sum of poles. So all of these are zeros. 0, you get 0 angle. And then for Bode plot, you must make sure to convert the magnitude in decibel. So you calculate 20 log m, okay, m of the overall transfer function. Okay, let's look at the next row. Let's say 0.1. So to get magnitude and angle, basically first you substitute 0.1 in W or omega. And then try plot in a S-plane. And then from there, you can determine the angle and magnitude. And repeat the process for all JW plus 20, JW plus 50, and 10,000. And then calculate the overall transfer function for M, magnitude, and the angle. And then for the magnitude, you need to convert into 20 log, okay, in decibel. Okay, so usually in question, let's say in your quiz question, you are given certain values of omega to use for your calculation. Okay, usually the question will be, will give you the value of omega. But in this example, it just want to show the value of magnitude and phase for different omega. Okay, so what it does basically use a lot of omega values. Okay, after you get all the values for magnitude and angle, then you can plot in a log scale graph. Okay, so this is magnitude plot in decibel, and this is the phase plot. Okay, so the plot is against frequency omega. So then you can determine the system stability. So in this example, it uses MATLAB. Okay, so to determine the system stability, basically first you need to look at the gain margin. So to determine gain margin, you need to first determine gain margin frequency. So gain margin frequency is the frequency at negative 180 degree of phase here. And then from here, you determine the gain and then find gain margin. The value of gain minus 0 decibel. So you get gain margin 19.7 at frequency 36.8. And then the next one is you need to determine the phase margin. So first determine phase margin frequency. So phase margin frequency is the frequency at 0 decibel here. And so phase margin is the phase difference of the of negative 180 minus the phase at phase margin frequency. Okay, so you get around 92.9 degree at frequency 7.74. So if is the system stable? So to determine stability, basically phase margin frequency must be less than gain margin frequency. So if phase margin frequency less than gain margin frequency, then the system is stable. So the frequency for phase margin is 7.74. Frequency for gain margin 36.8. So phase margin frequency less than gain margin frequency. So the system is stable. Okay, so you can determine gain margin and phase margin from your plot. Okay, also the same thing. Okay, so this is an example. Soalan.
Okay, tadi ni macam mana nak dapat dia punya 36.8 dengan 3174?
Okay, ni kalau dari graf ni, so dari graf ni first determine gain margin frequency. So gain margin frequency. So gain margin frequency is the frequency at negative 180 degree. So somewhere around here. Okay, ni nanti awak kena plot janganlah guna Excel, okay? Plot dalam kertas log paper, okay? Log graph paper. So ni dia punya nombor ni rasanya salah, okay? Nombor ni bukan nombor frekuensi ni. Okay, so gain margin frequency is somewhere around here. Maybe here. And then determine the phase margin frequency. So phase margin frequency is the frequency at 0 decibel. So it's somewhere here. Okay. So if you plot later in kertas yang cantik sikit, okay, log graph lah preferably. Boleh cari kat internet, okay. You can find log graph in internet. So you can get something the same as the one in MATLAB, okay. Okay, so there are two examples I gave in the slide, so you can, but the answer is in MATLAB. Okay, so you can try if you have time, okay, using log graph. Okay, so that's it for Bode plot. So you can try later answer quiz 13. So so I already list down the steps, okay. So try to use log graph you can get from internet, okay. Okay, so now we move on to Nyquist plot. So Nyquist plot is another way of showing or communicating the transfer function in terms of frequency. So the difference between Nyquist plot with Bode plot is that for Bode plot, the horizontal axis is in terms of log frequency, and the Bode plot has two separate plots, one for magnitude or amplitude and one for the phase. But in Nyquist, basically it plots both amplitude or magnitude and phase angle on a single plot. So using frequency as the parameter in the plot. So it's simple, meaning that you don't have to plot two separate plots, okay, like Bode plot. But Nyquist, you only plot one plot that display both amplitude and angle in the same plot. Okay, so the same step you need to do to plot Nyquist plot. Basically, first you convert S equals J omega, and then determine the phase, the angle, and the magnitude. So let's look at one example. So this is an example of Nyquist plot. So Nyquist plot will be plotted in S plane. Okay. So S plane. So in Bode plot, you plot the graph in logarithmic plot. But for Nyquist plot, you plot them in S plane. And for Nyquist plot, the shape will be like a seashell, okay, circle or whirlpool, okay. It will keep rotating, okay, until reaching maybe center here, okay. So in this plot, basically shows that apa ditunjuk ni? Okay, so not important. Okay, so in Nyquist plot, it also has gain margin and phase margin. But however, to determine gain margin and phase margin using Nyquist plot is very difficult to determine manually. So usually people use MATLAB to determine phase margin and gain margin in Nyquist plot, because you need to calculate something which is beyond the syllabus. But the important thing that you need to know is that is this point -1 here. So if your Nyquist plot intersect at real axis less than -1, for example, this blue line here, then the system is stable. However, if your Bode plot maybe intersect here, let's say for example, intersect here, which is more than -1, then this Nyquist plot is for unstable system. Okay, so you must make sure that, not make sure, but you need to look at where the Nyquist plot intersect on the real axis. If less than -1, then stable. If more, it's unstable. Okay, so this is what I said just now. If your Nyquist plot is before -1, then the system is stable. If it intersect -1, then the system is critically stable. If the Nyquist plot intersect values more than -1, okay, more negative, so the system is unstable. Okay, let's look at another example for Nyquist plot. Okay, so draw the Nyquist plot manually or using MATLAB from the system below. Okay, so this is the transfer function. So if you look in the quiz question, I already list down the steps to plot Nyquist plot manually. So first step, you need to convert S equals J omega. Okay. So first, convert all S equals J omega. So S equals j omega. So when you get s squared, you get j omega squared. So you get minus omega squared. So j squared is minus 1, okay? And then after that, you separate the poles and zeros on a separate column. So the first one is this red black box here in one column. And then this next one is j omega plus 2 in another column. And last one is the 0, 100, okay, in another column. And then calculate the magnitude and angle. Same method for Bode plot, okay, used in Bode plot. So calculate magnitude and angle for different frequency given. So you start with 0 and then 0.1 and so on. And then determine the overall transfer function. So same step as Bode plot, but this time you don't need to calculate the decibel, okay? Because decibel is only for Bode plot. Okay, so in this example, it uses variety of range for frequency. But if you look at the quiz 14, you are already given the frequency values that you need to calculate the magnitude and angle. Okay, so then you calculate all the magnitude and angle for each of the zero and poles, and then find the overall transfer function. And after you make the table, you can plot them in S-plane. So we start with the first point. Okay, so the first point is when frequency is 0. So the magnitude is at 16.67 at angle 0. So you put point here. And then you repeat the process for the second frequency. Second frequency, so you get plot somewhere around here. And then you connect the dots, okay? So this red line here is your Nyquist plot, okay? Not the black line, but the red line is Nyquist plot. And then you repeat the process for different frequency. You plot the dots, okay? And then connect the dots with a line. So these lines, the red lines here, are the Nyquist. Okay, repeat the process for each frequency. Then connect the dots, okay? So it's a good practice if you can plot the Nyquist plot using roughly I would say roughly the magnitude must be as you must plot the magnitude as equal as possible with 16.67, meaning that don't simply put 16.67 maybe here, okay, because later you want to compare with point minus 1. So if you plot the magnitude wrongly, then maybe your plot your Nyquist plot intersect at a different point, okay, so your conclusion will be wrong, okay. So to avoid wrong conclusion, you must make sure the magnitude is scaled accordingly, but the angle you can simply bantai lah, simply tembak, okay. Okay, so you don't need to use protractor to calculate the angle, but for the magnitude, try to use ruler as much as possible, okay, so that you plot the Nyquist plot intersect the x-axis, the real axis, at the right point, okay, so that you can determine whether the system is stable or not stable. So in this case, okay, ada soalan?
Yes, sir. Macam mana nak dapatkan 16.67 tu?
Okay, so kena kira magnitude. Oh, ni. Okay, so This is 16.67 just now. Okay. So you calculate magnitude for each pole and 0, and then find the product. Okay. So 100 divided by 3 and 2. So you get 100 divided by 6. Okay. So for example, the first frequency 0. So you get magnitude equals 3. Second one, you get magnitude equals 2. And the last one, the magnitude is 100. Okay. And then find the overall transfer function. So you use this value, the overall transfer function, and plot them in S-plane. Okay. So if the Nyquist plot intersect after -1, then the system is unstable. So if it intersect before -1, then the system is stable. Okay, so if you draw Nyquist plot manually, you will get only one part, okay, of the Nyquist plot, the actual Nyquist plot. But if you plot using MATLAB, you will see that it's symmetric about real axis and it has a circular shape. Okay. So here it intersects somewhere in here, I don't know where. Okay. Okay, so this is using MATLAB. Okay, I think that's it for chapter 5. Okay, so you can try to do quiz 13 for bot plot and quiz 14 for Nyquist plot. So maybe start with bot plot first, and then Nyquist plot will be much simpler because you already know how to plot using how to plot bot plot. Okay. Okay, so if you have any question, you can ask now. If you don't, then that's it for today's class. And inshallah, we will meet one more next week for final topic. And after that, habis dah.
Betul. Dan yang tu tadi tu yang betul tu.
Yang mana?
Yang -1 tu kalau lebih dia stable unstable.
Yes, like Nyquist plot if more than -1 is unstable. So this one unstable.
Memang just -1 lebih -1 memang unstable lah.
Kalau after -1 here unstable. Kalau before stable.
Oh.
Nyquist plot je, okay? Nyquist plot je. So don't mix up with root locus or bot plot, okay? Each of this plot have different ways on determining the stability. Okay, Nyquist plot, you need to look at -1 point here. For bot plot, you need to look at the gain and phase margin. And root locus, you need to look at whether the poles is on the right hand side or left hand side of the S-plane. So there are 3 ways on determining stability. So another way of determining stability is by root locus. Okay, so there are 4 ways, okay, to determine stability. Okay, so that's it for today's class.
Sir.
Okay.
Kita punya tujuan kita buat apa, plot duit apa, banyak plot ni kan, buat plot Nyquist apa semua root locus kan, nak determine stability je kan.
Yep, dia nak determine stability. Macam root locus, for example, root locus kita nak determine, we want to determine stability when we varies the gain K. For Rutherford's the table, we want to determine the stability without having to find the poles. So we don't need to find the poles, but we can determine the stability right away. But for bot plot and for Nyquist plot, we want to plot the transfer function in terms of frequency and then determine the stability. So maybe sometimes you want to see at what frequency is this system, either it's stable or not. Okay, so you want to evaluate them in terms of frequency. Okay.
Okay, sir.
All right. Okay, any more questions?
Sir. contohnya kan kita dapat stability dekat board plot tu. So contohnya kan kalau phase margin lagi kurang daripada gain margin tu kan dia lagi stable kan. Lepas tu kalau kita buat kat Nyquist plot tu mesti disable kan?
Yes, supposedly akan stable jugalah. Cumanya sometimes orang guna Nyquist plot ni dia rasa dia boleh dia kena baca sikit lah. Sometimes dia ada kegunaan lain. Tapi board plot ni usually orang guna nak tengok frekuensi lah. Sometimes dia nak tahu dekat frekuensi berapa magnitude dia berapa macam tu. So ada soalan lagi?
Ada. Contohnya kan dekat ni board plot kan. Board plot tu kan kita tengok kat transfer function tu kita tengok pole tu kita dah tahu dah macam dia stable kan. So kalau kita buat tiba-tiba dapat gain margin lagi tinggi tu maknanya salah tu kan kita buat.
Confirm salah lah. So itu antara cara untuk awak determine ataupun evaluate jawapan masa exam nanti. Tengok transfer function pun dah tahu dia ni stable. Tiba-tiba kira tak stable. Maknanya salah kira lah tu. Okay?
Okay sir.
Okay, so okay.
Satu lagi.
Tak apa, tanya je.
Tengok table yang Nyquist tadi.
Okay.
Dapat right? Ni table ni macam mana magnitude 01 tu kan dapat 3.05.
Yang ni ke?
3.05.
Okay, ni bila frekuensi 0.1. So bila frekuensi 0.1, first you calculate, you substitute 0.1 in here. So you get minus 0.1 square plus 3 plus 0.6J. So kira lah sikit. So 3 plus 0.1 square, you get 3.01. So you get minus. So you get 2.99. So 2.99 plus 0.6J. Okay, after you get this value, then you sketch roughly in S-plane. So 2.99 somewhere around here. 0.6J maybe somewhere here. Okay. And then buat satu garisan. And then calculate the magnitude. So magnitude is 2.99 squared plus 0.6 square root, okay? Square root 2.99 square plus 0.6 square. Okay. Kita abaikan tulisan yang buruk. And then the angle is this angle. Okay, so you use tangent. Okay, tangent minus 1. 0.6 over 2.99. Okay, so if your point maybe here, for example, then the angle must measured from real axis, okay? Just like you determine the magnitude and angle for complex number. Okay, same thing that you have done in root locus. Tak dengar suara.
Sir, tak dapat pun 35 tu.
Sekejap.
Tak dapat pun 3.05.
Rasanya ada silap kira ni. Sebab ni nota lama, okay? Harap maklum lah. Dapat berapa?
Angle pun tak dapat.
So yang 2.99 tu 0.1 square tambah 3.
0.1 squared minus sebab ada J squared.
Oh.
Ada J squared, dia jadi minus. So magnitude dapat 3.05. Betul. For angle you
Mana
get
dapat 3.05 tu sir?
ni lah 2.9 squared. 2.9 squared. Alamak.
Yang magnitude dapat, yang angle tu tak dapat.
2.99 squared plus
magnitude
0.6
dapat.
squared.
Angle
Tu rasanya salah kira kot.
Angle dapat 11 ke?
Dia sengaja nak bagi korang pening. Okay, tak dapat. Okay. Assume dia salah.
11.35 kan?
11 point something. 11.35.
Oh, maknanya depan pun salah juga yang untuk plot tu.
Ya kot.
Dia suruh student you lepas tu salah.
Dia nak bagi tricky lah. Dia nak bagi korang salah masa belajar. Masa final salah juga nanti.
Okay, thank you sir.
Okay. Tapi ni orang lama yang buat, okay. Mungkin dia soalan lain kot sebenarnya ke apa ke tak tahulah, okay. Tapi
ke orang lama tak habis belajar lagi.
Mungkin lah. Okay, tapi konsep dia ada lah, okay. Macam dia kira final angle tu adalah konsep dia, betul lah. Cuma dia kira ni salah, semua salah. Okay.
Terima kasih.
Alright. So the idea is there, but the calculation is wrong, okay. But the most important thing you need to do is calculate magnitude and angle, find the overall transfer function, and then plot them on S-plane for Nyquist plot. So plot the points and connect the points with a line, okay. So the lines that you connect between the points are the Nyquist plot. So the red line here, Nyquist plot, not the black one. So most students in previous semester, they do the black lines but not connect the points. So they lost half of the marks, maybe, okay? I don't remember. Because you don't plot Nyquist. So you are basically wrong lah, okay? So this red line is Nyquist, okay? Okay, any more question?
Sir.
Okay.
Table Nyquist tu dia bagi ke ataupun kita kena kira satu-satu sendiri?
Okay, so table ni dia tak bagi. Tapi kalau dalam soalan contohnya quiz 14 and quiz 13, you are given frequency, what frequency to calculate. So you buat table, you create table. So the step already state tabulate the values. So you create table starting from frequency 0.2 for example. So you buat table ni, okay, you do the table. And then calculate the angle, magnitude, find the overall transfer function. But only calculate for the angle given to you only, okay. You can calculate more frequency for the frequency given to you. So you can calculate more frequency, but basically you waste your time only, okay. Because you only need to calculate for this frequency given only. Okay, so there are 5 frequency given. But later maybe your board plot will be macam not smooth, maybe like bergerigi, something like that, okay. Not really smooth. That's totally fine. Maybe if you are OCD person or something like that, maybe you can do for more frequency if you have enough time. But if you don't, just calculate for the frequency given. Okay, but the difficulty maybe in finding the gain and phase margin later. Okay, but I think it should be fine for this question code, okay. So same thing for Nyquist plot, you are given certain frequency. So do the table for the frequency given, okay. Okay, that's all for the question. Any more question?
No sir.
Okay, so try to do the quiz. Maybe sebab tomorrow no, we don't have class, so you have plenty of time to do the quiz, okay? And next week we will cover our last topic on PID controller. And I'm not sure about your final exam, how it will be conducted. I'm not sure whether it's still the same final year answer first and then followed by those who are not final year. If separated, then there will be 2 sets of questions. Okay, so I don't want to discuss the question or to do the revision now. Maybe I will do the revision study week if we have time. Okay, so that's it for today. Okay, soalan.
UMP nak umum dia punya target exam tu?
Tunggu tunggu exam start kot.
Exam yang final year start lah.
tak tahu apa-apa ni. So tanya tu yang tanya korang.
Ini memang start bulan 8 lah kan.
So korang punya exam yang untuk final year tu rasanya dalam 3 minggu lagi kot, 4 minggu lagi kot.
Lepas tu
Dia ada budak final year.
Macam mana?
Mesti ada budak final year.
Ada. Ramai kot.
So kalau tak sama, doktor buatlah yang set 2 tu sama-sama akan sama dengan soalan final year tu.
Itulah sebab tak bincang lagi. Tak ada siapa buat lagi soalan set kedua. Tak ada siapa yang
Konsep
buat.
sama, just tukar nombor je sir.
Itu tak boleh lah.
okay tak?
Mungkin topik yang sama tapi soalan yang berbeza. Soalan yang memang lain langsung.
Dan sasar memang topik akan sama.
Sebab ada 4 soalan. So final nanti in final you have 4 questions. So what topics covered will be different. Like past year you have block the translational mechanics. Maybe this year you don't have translational mechanics, maybe gearing for example. So it depends on rasa nak bagi-bagilah macam tu.
Okay.
Tapi kita tunggulah UMP punya pengumuman macam mana. Rasanya macam synchronize kot.
Sampai berjanggut tunggu.
Itulah kita orang pun dah malas dah lantak kau lah situ.
Kata.
Macam mana?
Melego
Tempat
je.
soalan.
Ada 4 soalan. Main ego masa korang test. So ada 4 soalan. So satu soalan 25 markah. So total 100. Tapi nanti dia jadi 40% of overall assessment.
So untuk soalan set tu untuk set 1 lah sir, ke ada 2 set untuk budak yang final year dengan yang tak final year?
Planning dia nak buat 2 set tapi sebab hari tu macam kata UMP nak keluarkan perkeliling baru, pengumuman baru untuk synchronizkan semua exam tapi tak ada apa-apa pun. So kita tunggu je lah.
So kalau sir nak buat soalan untuk yang bukan final year student sir buat yang susah sikit sir. Yang final year
itulah nak buat yang bukan final year susah gila. Okay, ni senior yang suruh pergi pukul dia ramai-ramai.
Sir, yang final year bak susah habis extend sir.
cukup lah tu, tak nak duduk UMP dah.
Best way UMP. Makin maju. Okay lah. Okay, so kita continue next week. And thank you for today. And that's it. Okay, Assalamualaikum and goodbye.
Thank you sir.
Okay, bye. Thank you, welcome.